what is salt. Okay, the salt, definition of salt is nothing but it's just when an acid reacts with a base, then then the salt and water are formed. So where salt is nothing, so you can understand, you can recognize that acid is salt is nothing in non a single component, not a primary component. It's basically the combination of acid and base. When an acid is combined with a base, then salt and water has been formed. Okay, for example, you can see over here acid and base, which is formed water, salt and water. That means acid plus base, which is produced salt and water. Okay, so salt is nothing a primary component. It's the component which makes from the combination of acid as well as base. Okay, so I think you can understand that what is the definition of salt, or from where the salt has been come out. Now this equation, acid plus base to make a salt and water, how would you explain? Now I am going to explain in an example way, in a proper way. That is, suppose HCl, sorry, HCl. What is this? This is a acid, hydrochloric acid. Okay, and to HCl, if we combine with suppose NaOH, what is this? This is base. Okay, then what produce? Acid plus base, we connect to each other, we combine to each other, then definitely a salt has been produced. So the production has been came out, the output has been came out is NaCl. NaCl. Okay, so what is NaCl? NaCl, and this is base NaOH. So if we connect to each other, then the NaCl has been produced. Okay, so Na, from this Na portion we get this, and from Cl we get this. Okay, that's why we come. And what has been left? H and OH. So that is called H2O. That is water. Okay, so acid, we connect acid and base, and water has been produced. So what is this? This is definitely the salts, which is called sodium chloride. Okay, so you can easily understand that from the combination of acid and base, we can get salt, which is called sodium chloride, as well as water. Okay, so that is the main point. So sodium chloride is the, there are also another very salt, many salts in our nature. The NaCl, sodium chloride, is the food salt, which we take as a food. Okay, so this is the one. Now I am going to discuss that what is the uses of some important salts. There are lots of salts, I have already told you, that is NaCl, sodium iodide, calcium chloride, potassium nitrate, calcium sulfate. Okay, there are different kinds of salts are available in nature. So first the main point is NaCl, which I am going to produced from here. Acid plus base is equal to salt, NaCl. Now, what is the uses of NaCl? How we can use NaCl? NaCl is basically used in saline water for a patient of dehydration. 0.9% NaCl in manufacturing of HCl. So what is dehydration? Although I have already told you that if a man is going to be very sweat in a warm summer time, then his body has been, the level of their pH has been decreased and the acid has been formed in their body, which is called hydrochloric acid. So the due to the acid formation, the dehydration has been occurred. So to control this dehydration, we definitely use saline water. So in saline water, what has come in this saline water? In saline water, the main thing is came, which is salt. In saline water, the main component of the saline water is salt. Okay, so which control the dehydration. So what is the salt? That is NaCl. Okay, so that's why it's dictated that saline water for a patient is dehydration in manufacturing of HCl. Okay, so 0.9% HCl has been present in a saline water. Just take the point in your mind that if a question has been arising exam, then how much percentage of sodium chloride or salts has present in the saline water? Then it is 0.9% NaCl has been present in saline water. Okay, so apart from the NaCl, there are also various salts are available. Some like sodium iodide. Sodium iodide. So what is the uses of this sodium iodide salt? The uses of this sodium iodide salt is its iodide salt to prevent goiter disease. Suppose you know the goiter disease. What is the goiter disease? So basically the goiter disease is the problem or the disease which has been which are come due to the effective very dangerous virus which is attacked in our throat. So this is the goiter. Okay, this goiter disease is due to the deficiency of iodine has come in our body. Okay, so sodium iodide is nothing but the iodine, in which salt the iodine are present. So this iodized salt or sodium iodide is to prevent the goiter disease. Okay, so this is the uses of sodium iodide. Now the next is calcium chloride. Do you know the calcium chloride chemical formula? That is Na. Sorry, not Na. It's CaCl2. This is the formula of calcium chloride. This is also a salt. This is also a salt. This is also came from the acid plus base. Both together contain and the CaCl2, that means calcium chloride has been formed. This is a salt. So what is the uses of this salt, calcium chloride? The uses of calcium chloride is to dehydrating agent used for removing moisture from gases. Suppose in our body, or in our body contains lot of gases. Due to the gases, our body skin has been going to moisture or dry. Due to the presence or absence of gases, our skin is moisture or dry. So uh, this calcium chloride is used as a dehydrating agent. It is basically used as a dehydrating agent in our body, not only our body but also in any kind of animal body. Dehydrating agent used for removing the moisture from the gases. So if in our body, if the moisture portion has been removed, then definitely the body is going to be dry. Okay, so this dry of our body temperature, to make it dry, the calcium chloride salt has to be used. Okay, so this is nothing but an external agent which is worked in our body to remove the moisture from the gases. Okay, so this is an external agent or dehydrating agent used as a dehydrating agent in our body. This is the uses of calcium chloride. So in three salts, I explained all the thing. NaCl, the use of NaCl, which is used as saline water for a patient for dehydration of our body. Sodium iodide, I already told that sodium iodide is nothing but a iodine which is prevent goiter disease, which are basically due to the efficiency of iodine, are this disease are happen in our throat, and this is nothing but the some effective virus. Okay, and the third one is calcium chloride, which is the dehydrating agent used for removing of moisture from the gases. Okay, now I come to the fourth point, fourth uses of salts, the which is called potassium nitrate. Do you know the chemical formula? Chemical formula of potassium nitrate is KNO3. NO3 is called nitrate bond and K is the symbol of potassium. Together they are called potassium nitrate. Similarly, it also comes from a acid plus base bond. This salt has been come out. Okay. So what is this salt? What is this potassium nitrate salt uses? Definitely, it is the very essential and very effective uses salts. What is their uses? Number one, it is used in fertilizer, both K and N. Fertilizer. Fertilizer are basically fertilizer to make a fertilizer in land, to make a fertilizer for any kind of vegetables. We basically used fertilizer to make a vegetables in land properly, to grow properly. We basically used fertilizer. To make this fertilizer, we are definitely used potassium as well as nitrogen together. Okay, so together potassium plus nitrogen together make fertilizer, which is enhance the growth of a vegetables in a land. Okay, so this potassium nitrate used as in fertilizer. Okay, the next use of potassium nitrate is it's used in gunpowder. Okay, C plus S plus K energy. That means to make a gunpowder in gun factory, definitely potassium has to be used. That is KNO3. The chemical solution to make a gunpowder is KNO3 plus C plus S. That means potassium nitrate, C for carbon and S for sulfur. Together they make gunpowder. To make this gunpowder, we definitely use potassium nitrate. Okay, So this is the another uses we can get. The last is to make the match sticks. To make the match sticks. Suppose to make a match sticks in this portion. In this portion, this is nothing but the combination of carbon and KNO3. In a match, suppose it is a matchstick. This portion is making from the combination of C and KNO3. C is for carbon and KNO3 is potassium nitrate. Okay. So that is the uses of among all the salts, the use of potassium nitrates are very much effective. Okay. So the fourth, the last and fourth use important salt which to be used in our daily life, that is calcium sulfate. It is very, very important. The chemical formula of calcium sulfate is 2CaSO4 2H2O. Okay, this is calcium sulfate. This is the chemical formula of calcium sulfate. Basically, it's nothing but called plaster of Paris. I think all my students heard the name of plaster of Paris. Okay, plaster of Paris. So what is the uses of this plaster of Paris in our daily life? Okay, so definitely calcium sulfate or plaster of Paris used for molds and statue. You can see different statue. Some statue has been made with plaster of Paris because it's almost like a cement or strong base. So the mold and statue has been making to make a mold or statue. Plaster of Paris is very much useful. Okay, some of the students or some of my students also having some school project to make a models or statue. They definitely use plaster of Paris. How the plaster of Paris has been used? It's basically used in a basically a powder. The water has to be mixed with them, and after a certain time, it's going to be hard or stiff. So this is basically uses to make a mold or statue. This is the number one usage. What is the number two usage of plaster of Paris? The number of usage of plaster of Paris, also the calcium sulfate or plaster of Paris is used as gypsum, which is used in a cement industry. To make a cement, as it is very hard, that's why it's used to make a cement. To make a cement, a component, a very essential component has to be mixed with the formation of a cement, which is called gypsum. This gypsum is nothing but calcium phosphate. This gypsum is nothing but the calcium phosphate. What is buffer solution? Do you know what is the buffer? The term buffer is used. Buffer is solution. Buffer is nothing but the mixture. Okay, this is called a buffer solution. So what is buffer solution? A solution whose pH is not altered to great extent by the addition of either acid or base is called buffer solution. That means in a solution, whose pH is not altered to great extent. The solution whose pH is not altered to great extent by the addition of either acid or base. That means, suppose if you are connect a acid with a base, that at that time the quality of base has to be opposite of the uh, acid. That means, when basically when you contrast a weak acid with a strong base, the buffer solution has been made. Similarly, when you made the strong acid with weak base, this is called buffer solution. That means, I have already classified you acid two types. One is strong and one is weak. Similarly, base also two types. One is strong, one is weak. So when the strong acid with weak base has been connected, this is called buffer. Similarly, when the weak base with strong weak acid with strong base has been connected, this is also called buffer solution. Okay, so I think you got my point. So what are the weak acid? I already discussed this. You can get from my previous previous video. You can get. Okay, so it's nothing but the alter way. This is nothing but the opposite way. Weak acid with strong base is called buffer, as well as strong acid with weak base is also called buffer. So that's why it's defined as pH is not altered to great extent by the addition of either acid or base. Acid means H plus and base means OH minus. Okay, so this is called buffer solution. Now, buffer solution, an example of buffer solution I want to give in last of my topic, that is buffer action of blood due to presence of H2CO3 and HCO3. If we combine our blood, if we combine buffer solution in our blood, buffer solution in our blood, if we combine buffer solution in our blood, then definitely it has to be presence of, it has to be components of H2CO3, that means carbonic acid, and HCO3. Okay, so to make a buffer action on our blood, we have to present H2CO3 and HCO3. This is -1. Okay, if these two chemical bonds are present in our blood, then definitely our blood has to be in buffer solution. Okay,